Welcome to the peaceful space of sleep-friendly science, where tonight we drift back through the veils of deep time to witness a world on the very brink of the greatest catastrophe life has ever known, the Permian Extinction. As the world outside quiets down, let your mind gently unwind. There's no need to follow every detail. Simply allow your curiosity to float on the sound of my voice. Let these ancient whispers from a lost earth become the landscape for your dreams tonight, a gentle current to carry you toward rest. Now settle in, take a deep breath, and let the soft sounds guide you as we begin tonight's journey into the unknown. Section 1. The World Before the Silence. Imagine, if you will, that your consciousness is a single weightless seed, drifting on the winds of time. Let it float backwards past the age of humans, past the reign of the dinosaurs, further and further still, until you land softly in a world that is at once both alien and hauntingly familiar. We have arrived in the late Permian period, some 252 million years ago. The Earth you land upon does not have the familiar patchwork of continents we know today. Instead, there is one single vast heartland, a supercontinent called Pangaea. It stretches from pole to pole like a great, sleeping giant, its coastlines wrapped around a single immense global ocean, Panthalassa. To stand in its center is to be further from the sea than is possible on our modern Earth. It is a world of immense scale, of profound continental stillness, the slow, deep breath of a world that has known this shape for millions of years. Let your senses adjust to this ancient air. It is thicker, richer in oxygen than our own, carrying strange earthy scents. The sun feels different here too. It is a younger star, slightly less intense, and its light filters through the atmosphere with a soft, almost golden quality. The sky above is a familiar blue, but it feels vaster, more immense, arching over a singular landmass. We find ourselves not in the harsh, dry heart of the continent, but near its greener fringe, where moisture from the great ocean can nourish life. You are standing at the edge of a forest unlike any you have ever seen. There are no flowers here, no vibrant petals to catch your eye. There is no grass beneath your feet. The color palette of this world is a deep and subtle one. Greens, browns, and the rich dark soil. The dominant trees are the Glossopteris, the so-called tongue-leaf trees. They are the pillars of this Permian world, rising tall and sturdy, their long tongue-shaped leaves forming a dense rustling canopy high above. They are not conifers, nor are they flowering trees. They are something else entirely, a form of life that found its perfect moment in this time and place. The air beneath their canopy is thick and sweet, smelling of damp earth, slow decay, and the strange resinous perfume of these ancient trees. Light dapples the forest floor, painting shifting patterns on vast fern prairies and groves of armored cycads, which stand like stoic, pineapple-like sentinels in the undergrowth. The sounds are of the wind in the leaves, the hum of insects, and the gentle, constant trickle of water through mossy stream beds. This world is not silent. It is teeming with life, but the voices are strange to our ears. Listen closely. That low, rumbling sound, like a herd of cattle moving through the brush, is a group of Scutosaurus. Imagine great, armored fortresses of flesh and bone, each the size of a modern ox, but built low to the ground. Their hides are studded with bony plates, called scuts, and their faces are lumpy and knobbed, giving them an almost grumpy, endearing expression. They are powerful herbivores, moving slowly and deliberately through the ferns, their immense weight shaking the very ground. They are the great lawnmowers of the Permian, living tanks that are almost impervious to attack. Almost. From the deeper shadows of the Glossopteris forest, another creature emerges. It moves with a terrifying grace that belies its bulk. This is the apex predator of this world, a Gorgonopsian. Imagine a creature that is part wolf, part lizard, and part nightmare. It is a synapsid, a mammal-like reptile, belonging to the same broad family tree as us, but it has taken a very different evolutionary path. It walks on 4 powerful legs, its body lean and muscular, and its head is long and formidable. And from its upper jaw, two enormous dagger-like canine teeth protrude, gleaming like polished ivory. This is a saber-toothed tyrant, and its gaze holds no warmth, only a cold, calculating hunger. It watches the herd of Scutosaurus, its mind, ancient and primal, weighing the risk and the reward. For millions of years, this has been the central drama of Pangaea, the dance between the armored herbivore and the saber-toothed killer. But not all life here is so grand or so terrifying. Look down at the forest floor, near the damp roots of a giant horsetail plant. There, waddling through the leaf litter, is a creature that seems almost comical in this land of giants and monsters. It is about the size of a small pig, with a stout barrel-shaped body and a short, stubby tail. Its face is peculiar, ending in a blunt, turtle-like beak. Two small tusks, like those of a walrus, jut down from its upper jaw. This is a Lystrosaurus, a type of dicynodont, one of the most common and successful plant eaters of its time. They are everywhere, snuffling and digging for roots and tubers with their powerful beaks. They are unassuming, seemingly insignificant, just part of the background scenery of this vibrant world. They are the survivors of our story, though they do not know it yet. They simply live, day by day, in the shadow of the great Gorgonopsians and among the herds of Scutosaurus. The waterways, too, are full of life. In the sluggish, meandering rivers, great flat-headed amphibians like Archaeops lie in wait, some as long as a small crocodile, their skin like wet moss, their wide mouths ready to snap shut on any fish that swims too close. And in the air, insects buzz with an unfamiliar size and boldness. Dragonflies with wingspans like a hawk's flit through the air, their iridescent wings catching the golden light like shards of stained glass. This is a world in balance, a complex, intricate web of life that has been woven over tens of millions of years. It is a stable world, a successful world. The climate is relatively warm and steady. Life has conquered the land and filled every available niche, from the smallest burrower to the largest predator. The rhythm of this world feels eternal, a slow, deep pulse of seasons, of birth and death, of predator and prey. As we linger here, let us feel the profound peace of this moment. The sun begins to set over the single immense continent. The light softens, turning the sky from sapphire to shades of orange, rose, and deep violet. The air cools. The great Gorgonopsian melts back into the shadows, its hunt postponed for another day. The Scutosaurus herd settles down, their great bodies forming a protective circle. The little Lystrosaurus finds a shallow burrow to wait out the night. The nocturnal creatures begin to stir. The world exhales a cool sigh of relief. In this moment, there is a deep and abiding tranquility, a perfect fragile balance held in a single golden breath. The planet is blissfully unaware that deep beneath its crust, in the heart of what we would one day call Siberia, a cataclysm of unimaginable scale is beginning to stir. The furnace is lighting. The pressure is building. The world before the silence is living out its final peaceful days, completely oblivious to the fire that is about to be unleashed from below. Section 2: Whispers from the Deep. Now let us leave the sunlit surface of Pangaea, with its rustling forests and its strange, majestic beasts. Allow your awareness to sink downwards like a stone through water, passing through the rich soil, through layers of ancient, compacted rock, deeper and deeper into the planet's heart. We are descending into the Earth's mantle, a vast, slow-moving ocean of silicate rock, churning in currents that move on timescales of millions of years. It is a place of immense pressure and unimaginable heat, the engine room of our world. And here in the deep, a process began long before the first Gorgonopsian ever hunted. A flaw, a fever, a concentration of heat far below the surface began to coalesce. Imagine it as a deep and troubled dream within the planet's subconscious. A vast plume of superheated mantle rock, lighter and more buoyant than its surroundings, began its slow, inexorable ascent. This was no sudden eruption, not yet. This was a process of immense geological patience. For millions of years, This colossal bubble of heat and molten rock, wider than any mountain range on the surface, rose through the sluggish mantle like a ghostly thermal jellyfish, pushing upwards towards the planet's cool, fragile skin, the lithosphere. This is the great beast of our story, the prime mover of the coming devastation. We call it a mantle plume. It carried with it the primordial heat of the Earth's formation. As it neared the crust in that particular location we now call Siberia, the pressure it exerted was immense. The crust above it began to bulge, to thin, to grow brittle, like glass held too close to a flame. The ground on the surface, for thousands of square kilometers, would have domed upwards by hundreds of meters, a slow, silent swelling that the creatures living there could never have perceived. The deep foundational rock of the continent was groaning under the strain. The plume was knocking at the door from below. And then the door broke. It did not happen with the singular, explosive bang of a classic volcano like Vesuvius or Mount St. Helens. That is a small and localized anger. This was something far more vast, a planetary wound. The crust did not just break at one point, it tore. It unzipped. Great fissures, some stretching for hundreds of kilometers, ripped open across the Siberian landscape. Imagine standing there in that ancient twilight. The very ground, the solid foundation of the world, splits apart. Not with a clean crack, but with a deep guttural roar that is felt more than it is heard, a vibration that shakes the bones of every living thing for 1,000 miles. And from these fresh wounds in the earth, the world begins to bleed fire. There are no mountains here, no cones. Instead, from these vast cracks, curtains of fire, hundreds of meters high, leap into the sky. Fountains of incandescent rock, brilliant orange and white, pulse and surge, a horrifying and beautiful spectacle against the darkening sky. And from them a new kind of river is born, a river of basaltic lava, black and shimmering with heat. It is not thick and pasty like some lavas. It is thin, fluid, and terrifyingly fast. It pours from the fissures not as a slow crawl, but as a flood. This is the beginning of the Siberian traps, one of the largest known volcanic events in Earth's history. The term traps comes from the Swedish word for stairs, because the successive layers of cooled lava would later form a landscape of giant, step-like hills. But in this moment there are no stairs. There is only the flood. A black incandescent tide spreads across the land, consumes everything. The ancient Glossopteris forests, which had stood for millions of years, are engulfed in an instant. They do not simply burn, they are vaporized, their substance turned to gas and ash, their memory swallowed by the molten rock. The herds of Scutosaurus, the prowling Gorgonopsians, the burrowing Lystrosaurusini life caught in the path of this initial outbreak is simply erased. The lava advances relentlessly, filling valleys, damming rivers, creating new, temporary lakes of fire. The air itself shimmers and distorts with the heat. This is not a one-time event. The fissures pulse and flow for centuries, perhaps for millennia. Layer upon layer of lava is laid down, burying the landscape under a blanket of black rock that will eventually be kilometers thick. The area covered is immense, ultimately larger than Western Europe, a new sterile volcanic province imposed upon the living world. A black ocean of rock, still cooling and steaming, replaces a green and vibrant ecosystem. But the lava, as devastating as it is only the most direct and localized killer. The true global catastrophe comes from what this planetary hemorrhage releases into the sky. As the lava pours out, it also cooks the rock it travels through. Vast deposits of coal and carbonate from earlier geological ages. It is like a planetary-scale blast furnace. And so the air begins to fill with invisible poisons. From the fountains of fire and the vast steaming lava fields, a cocktail of gases is injected into the atmosphere on a scale that dwarfs anything modern humanity has ever produced. First, there is carbon dioxide, CO2, the breath of the volcano. Released by the billions of tons, it begins to accumulate in the sky. A transparent heat-trapping blanket that will, in time, change the very thermal balance of the planet. With it comes sulfur dioxide, SO2. This gas, sharp and choking, reacts with water vapor in the atmosphere to form tiny droplets of sulfuric acid. A fine, glittering haze begins to spread across the globe, a shimmering, deadly aerosol that will have its own profound effect on the world below. And there are other things too. Chlorine, fluorine, corrosive gases that were locked in the rock, now liberated to attack the very fabric of the atmosphere. The composition of the air, the very breath of the planet, is beginning to change. Thousands of miles away from the fire fountains of Siberia, the creatures of Pangaea would have noticed the first strange signs. Perhaps a persistent haze begins to dim the sun, making the golden light of the Permian afternoon seem a little weaker, a little colder. Perhaps the sunsets and sunrises become unnaturally, violently beautiful, painted in lurid shades of red and orange by the spreading volcanic dust. A fine gray powder, light as a whisper, begins to settle on the leaves of the ferns and the armored backs of the reptiles. It has no smell, no immediate threat, but it is the first messenger of the apocalypse, an ashfall that has traveled halfway around the world on the high winds of the stratosphere. The deep whispers from the Earth's mantle have now reached the sky, and they are about to become a scream. Section 3: The Poisoned Sky. The world does not yet know it is dying. It only knows that it is changing. The fine gray ash that settled on the great fern prairies was just the beginning, a whisper before the storm. The real assault is more subtle, more pervasive. It is happening high above, in the thin, cold air of the stratosphere, where the volcanic plumes have delivered their chemical payload. Remember the sulfur dioxide? A gas sharp and invisible, now pouring into the upper atmosphere by the millions of tons. Here, kissed by the unfiltered rays of the sun, it meets with water vapor, and a terrible alchemy takes place. The gases transform into a mist of tiny sulfuric acid droplets. An aerosol. From the ground it would not look like a thick black cloud. It would be a high, thin haze, a shimmering, almost beautiful veil that begins to stretch across the globe on the jet streams, a shroud of glittering microscopic crystals. This shroud is a mirror, a vast planetary-scale mirror that is slowly being assembled over the world. It reflects sunlight, the warm, life-giving energy that powers the entire terrestrial ecosystem, is now being met with this shimmering barrier and turned back into the coldness of space. And so the light begins to fail. Not all at once. It is not a sudden plunge into darkness. It is a slow, inexorable dimming. Day by day, the sun seems a little more distant, its light a little less potent. The brilliant gold of the Permian afternoon softens to a pale, watery yellow. The shadows lose their sharp edges, becoming vague and soft. The world is plunged into a perpetual gloomy twilight. A volcanic winter begins its reign. Imagine the confusion of the creatures on the ground. The great Gorgonopsian, a creature ruled by the rhythms of light and dark, finds the days growing short and strange, the optimal hunting hours confusingly extended yet drained of their vital energy. The herds of Scutosaurus, their cold-blooded bodies dependent on the sun's warmth to fuel their massive frames, become sluggish and slow. They huddle together for warmth, their movements lethargic, their ancient instincts screaming that something is profoundly wrong with the sky. But the most profound impact is on the foundation of all life, the plants. Photosynthesis is a miracle of turning light into life. But it requires light. As the world dims, the great Glossopteris trees, the pillars of this world, find their energy income dwindling. Their growth slows then stops. They are starving in the gloom. The vast understory of ferns, which thrive in lower light, are at first less affected, but even they begin to feel the chill as the average global temperature begins to fall. The planet, wrapped in its acidic blanket, is getting colder. And then the sky begins to weep. The sulfuric acid aerosols cannot remain in the stratosphere forever. Gravity and the planet's weather systems slowly pull them down into the lower, thicker atmosphere, the troposphere where clouds are born. Here, the acid droplets become the very seeds around which raindrops form. When the rain comes, it is no longer the clean, life-giving gift it has always been. It is a slow, persistent drizzle of acid. It is not a Hollywood acid that dissolves flesh on contact. Its malevolence is more patient. The rain that falls on the Glossopteris forests has the pH of vinegar. It lands on the waxy, protective coating of the leaves and begins to dissolve it. It sears the delicate tissues of the ferns, leaving them pockmarked with brown dead spots. The forest, which once smelled of damp earth and resin, now carries a faint, acrid scent after every shower. The leaves of the trees begin to look burned, tattered, and sick. The vibrant green of Pangea's plant life fades to a jaundiced, sickly yellow-brown. The very skin of the living world is being chemically burned, slowly, relentlessly, from the sky. This acidic rain seeps into the soil, changing its chemistry, locking up some nutrients while washing away others. The streams and rivers, once teeming with life, begin to feel the poison. The great, crocodile-like amphibians, with their sensitive, permeable skins, are among the first to suffer. The water burns them. Their gelatinous eggs laid in the shallows have no protection. The acid denatures them, turning them into cloudy, lifeless masses. The rivers begin to run unnaturally clear, not a sign of health but of death. The algae, the fish, the very bedrock of the aquatic food web is dissolving. And the volcanoes in Siberia continue to erupt. The fissures continue to pour fire and gas into this wounded atmosphere. They also pump out other chemicals, halogens like chlorine and fluorine. These gases rise high into the stratosphere and begin a different kind of assault, this time on the planet's invisible shield, the ozone layer. The ozone layer is a delicate concentration of molecules that absorbs the most harmful high-energy ultraviolet, or UV radiation from the sun. It is what makes the surface of the Earth habitable. But the volcanic chlorine acts as a catalyst, a microscopic vandal that can destroy thousands of ozone molecules without being consumed itself. The shield begins to shred. It develops holes, vast, continent-sized weaknesses. This creates a cruel paradox for the life below. The world is trapped in a dim, cold twilight by the sulfur aerosol shield. But the light that does struggle through this haze is now laced with a new, invisible venom. The UV radiation bombarding the surface increases dramatically. For any plant, this radiation damages the delicate cellular machinery of photosynthesis. For any animal, it burns skin and causes mutations in its DNA. The world is now caught in a terrible crossfire. It is too dark and too cold for life to thrive, and the light that remains is poisonous. The fundamental rules of existence have been broken. The sun, the source of all energy, is now a dim and dangerous ghost. The rain, the bringer of all moisture, is now a corrosive poison. The great forests of Pangaea are dying. Not by fire, not by flood, but by a slow systemic poisoning. They stand like gray ghosts, their leaves tattered, their growth stunted. And as the forests sicken, the creatures that depend on them begin to starve. The great herds of herbivores find their food becoming scarce and unpalatable. The carnivores who hunt them find their prey growing weak and thin. Famine on a global scale begins to set in. The air is cold, the light is wrong, the food is gone, and the rain is poison. The sky, once the symbol of constancy and life, has become an agent of death. And all this time the acid rain has been falling not just on the land, but on the surface of the great global ocean Panthalassa. For now the ocean is so vast that this seems like a minor insult, a few drops of poison in a boundless cistern. But the ocean has its own tipping points, its own thresholds for disaster. The crisis in the sky is now seeping into the cradle of life, and a new, even more terrifying chapter of the extinction is about to begin in the silent depths. Section 4. The Breathless Sea. Let us now turn our attention away from the dying forests of Pangaea and sink beneath the surface of the great global ocean Panthalassa. For millennia, this vast expanse has been the planet's stable, beating heart, its depths holding a repository of life far older and more diverse than anything on the land. Here, in the sunlit upper layers, are the equivalents of the Glossopteris forests, the sprawling microscopic gardens of phytoplankton. These tiny organisms are the true lungs of the Permian world, performing the bulk of its photosynthesis, creating oxygen and forming the base of a food web that stretches down into the abyss. This sunlit zone teems with life. Coral reefs, built not by the modern corals we know, but by different, more ancient organisms called rugose and tabulate corals, form vast, intricate cities beneath the waves. They are teeming with trilobites, those iconic armored arthropods that have scuttled across the seafloor for over 250 million years. There are brachiopods, shelled creatures that look like clams, but are from a completely different lineage, filtering food from the water with delicate, feathery organs. And swimming through this world are ancient fish, sharks of strange and wonderful design, and the coiled-shelled ammonites, jetting through the water like predatory squid in portable fortresses. The Permian Ocean is a riot of successful, specialized life. But now the poison from the sky begins to arrive. The acid rain, which has been scourging the land, falls upon the ocean's surface across millions of square kilometers. At first, the ocean's immense volume and its natural buffering capacity, a chemical resilience derived from dissolved minerals, absorb the blow. But the assault is relentless. For thousands of years, the rain of acid continues. The surface layer of the ocean begins to change its chemistry. It becomes more acidic. For the creatures that build shells, this is a death sentence. Their shells are made of calcium carbonate, a mineral that dissolves in acid. For a brachiopod, an ammonite, or a coral, it is like living in a house that is slowly dissolving around you. The very water becomes corrosive. For the adults, building and maintaining their shells becomes energetically impossible. But for their larvae, the tiny free-floating young that are the future of their species, the situation is even worse. They cannot even begin to form their protective skeletons in the acidified water. They simply dissolve. An entire generation and then the next fails to materialize. The great reefs, the product of millions of years of slow, patient growth, stop growing. They begin to pale, to crumble, to die, their intricate structures slowly dissolving back into the hostile water. The ocean is losing its bones. At the same time, the terrestrial crisis adds another layer of destruction. On the continents, the dying forests and eroding, vegetation-stripped soil can no longer hold the land in place. Every acidic rain shower now becomes a torrent of mud and sediment, washing immense quantities of silt, clay, and nutrients from the dying continent into the coastal waters. The sunlit shallows, once clear and vibrant, become choked with mud. The water turns murky and brown, further starving the phytoplankton and the already struggling reefs of light. The filter-feeding organisms, like the brachiopods and the sea lilies, are overwhelmed, their delicate feeding apparatuses clogged with silt. The coastal ecosystems, the nurseries of the ocean, are being smothered. But the most insidious killer is yet to come. It is not the acid nor the mud. It is something far more fundamental, the loss of breath. As the planet cools under the volcanic haze, the ocean's circulation patterns begin to falter. Normally cold, oxygen-rich surface water at the poles sinks and flows towards the equator, carrying life-giving oxygen into the deep ocean. But with the world in a global twilight, this ocean conveyor belt weakens, slows, and perhaps, in some places, stops altogether. The deep ocean is no longer being ventilated. Simultaneously, the deluge of nutrients, the washed-out remains of the dead continents triggers a monstrous bloom of bacteria in the surface waters. These bacteria feast on the dead organic matter, and in doing so they consume vast quantities of dissolved oxygen, like a fire sucking the air out of a room. The surface waters, once a source of oxygen, are now becoming depleted. The ocean begins to stratify. A grim layering effect takes hold. At the top, a thin, toxic, and increasingly acidic layer. choked with mud and oxygen-consuming bacteria. Below it, the deep ocean, now cut off from its supply of fresh oxygen, begins to suffocate. The life that has thrived in the abyss for eons, adapted to darkness and pressure, but not to a lack of oxygen, begins to die. A slow, silent, and invisible mass extinction is taking place in the dark. And as these deep-water organisms die and rot, the process consumes what little oxygen remains, accelerating the crisis. The deep water becomes what scientists call anoxic, utterly without oxygen. And then it becomes something worse. Euxinic. In the absence of oxygen, a different kind of microbial life begins to thrive. These are sulfate-reducing bacteria. They don't breathe oxygen, they breathe sulfate, a common ion in seawater. And as they do, they produce a deadly byproduct, hydrogen sulfide, H2S, poison. To us it smells of rotten eggs. To most aerobic life, it is a potent toxin that shuts down the cellular process of respiration. The deep ocean, once a sanctuary of life, is turning into a vast reservoir of poisonous, purple-tinged, hydrogen sulfide-rich water. This toxic anoxic layer begins to grow. It expands upwards like a malevolent ghost rising from the abyss. The boundary between the oxygenated surface world and the poisonous deep, known as the chemocline, begins to rise towards the light. Imagine being one of the last fish swimming in that dwindling surface layer. Below you is no longer a dark but living abyss. It is a wall of poison. The habitable zone of your world is becoming a wafer-thin film on the surface of a dead planet. And that film is shrinking. Day by day, the purple sulfitic water rises, killing everything it touches. The last of the trilobites, the last of the deep-water fish, the last complex organisms are extinguished as this toxic boundary sweeps past them. The ocean, the cradle of all life on Earth, is transforming into a planetary-scale gas chamber. The vibrant, breathing Panthalassa is dead. In its place is a stagnant, stratified, poisoned sea, silent and suffocating. The great extinction in the oceans is nearly complete. 95% of all marine species will be wiped out. The trilobites, which survived for 250 million years, are gone forever. The great rugose coral reefs will never be seen again. The ocean has become a tomb. And the hydrogen sulfide, bubbling up from the microbial underworld, does not stay in the water. It begins to leak out of the ocean and into the atmosphere, adding its own deadly signature to the already poisoned sky. The great dying is about to enter a new and even more hellish phase. The cold is about to give way to a terrifying, suffocating heat. Section 5. The planet's fever. The reign of the volcanic winter was a cruel paradox, a darkness that burned. But it was, in the grand scheme of planetary time, mercifully brief. The tiny droplets of sulfuric acid, the glittering dust that formed the sun-reflecting shroud, could not hang in the sky forever. Over centuries, they were washed out by the very acid rains they created, returning the sky's transparency. But this was no joyful dawn. There was no return to the golden light of the Permian. When the sun's full force returned to the earth, it was not as a gentle savior, but as a wrathful, avenging eye. The world had exchanged one executioner for another. The cold, dark gloom was replaced by a suffocating, feverish glare. Remember the other gas, the less conspicuous poison that had been pouring from the Siberian traps all this time? Carbon dioxide. While the sulfur aerosols created a temporary cooling, the CO2 was playing a longer, more patient game. It had been accumulating relentlessly, invisibly, wrapping the planet in a transparent blanket that was growing thicker with every passing century. This is the greenhouse effect, a name that sounds gentle, evoking images of nurturing warmth. But what was happening to the Earth was no gentle nurturing. It was a planetary fever spiraling out of control. The returning sunlight poured through the atmosphere, struck the ground and the sea, and radiated back as heat. But this heat could no longer escape. The thick, carbon-rich atmosphere trapped it, reflecting it back down. The planet had lost its ability to exhale into the cold of space. It was like a furnace door had swung shut, locking the heat inside. The temperature began to climb, not by a degree or two but by 5, then 10, then perhaps as much as 15 degrees Celsius on a global average. This is a number so abstract it's difficult to grasp, so let us feel it instead. The air itself becomes a physical burden. It grows thick, heavy and soupy with humidity as the warming oceans evaporate vast quantities of water. The equator, once a zone of vibrant tropical life, becomes a dead zone, a belt of lethally hot temperatures that may have exceeded 60 degrees Celsius, 140 degrees Fahrenheit, in the shade. To breathe this air is to feel your lungs scalded. The oceans, the great thermal regulators of the planet, offer no relief. They are turning into a planetary-scale warm bath. The temperature difference between the poles and the equator, the engine that drives wind and ocean currents, collapses. The world falls into a terrifying stagnant calm. There are no breezes to stir the thick air, no storms to break the monotonous heat. The sea, once a dynamic system of currents, becomes sluggish and still, further reinforcing the stratification and anoxia we witnessed before. Warmer water holds less oxygen, so even the thin surface layer, the last refuge for life, begins to suffocate in the heat. On the single great continent of Pangaea, the heat is remorseless. The land bakes. The sun beats down from a brassy, cloudless sky. The ghost forests of sickened Glossopteris, which survived the acid rain and the volcanic winter, now face a new torment. They are cooked where they stand. Their remaining leaves wither and crisp. The damp earth turns to brick. The rivers, already acidic and choked with mud, begin to evaporate, leaving behind cracked, sterile flats crusted with salt and minerals. Water becomes the most precious commodity in the world, and it is vanishing. What of the creatures that survived the cold and the dark? The last of the great dynasties of the Permian now face their final trial. Imagine the mighty Gorgonopsian. Its powerful muscular body, once an asset, is now a fatal flaw. It is a furnace with no way to cool down. It pants in the stifling air, its saber teeth seeming like a cruel joke in a world where there is nothing left to hunt but shadows. It seeks shade, but the skeletal trees offer none. It seeks water, but the riverbeds are dust. Its own powerful metabolism, which once fueled its predatory prowess, now cooks it from the inside out. The great, lumbering Scutosaurus herds meet the same fate. Their massive bodies, covered in bony armor, are slow to heat up but also slow to cool down. They are trapped within their own shells, slow roasting under the relentless sun. The last of these once mighty creatures simply lie down in the searing heat and die. Their passing is not marked by a dramatic final battle, but by a slow, silent, undignified surrender to the sheer physics of a world that has become too hot to support their size. The giants are falling. The intricate ecosystems they anchored are gone. The world is being simplified, stripped back to its harshest elements. But in the cracks of this dying world, life, in its most tenacious forms, clings on. Remember the small, unassuming Lystrosaurus? The pig-sized creature with the tusks and the beak. Its small size is now an advantage, allowing it to shed heat more easily. More importantly, it is a burrower. While the surface world bakes into a sterile crust under the midday sun, the Lystrosaurus can retreat into the relative cool of the earth. Its simple, robust way of life, digging for the tough, starchy roots and tubers that can survive in the traumatized soil, allows it to eke out a living where others starve. It is not thriving. It is enduring. It is a refugee in its own time, hiding from the sky. The planet's fever is raging. It has broken its own thermostat. The carbon cycle, the intricate dance of carbon between the atmosphere, oceans, and life, is completely shattered. The volcanoes continue to pump out CO2. The oceans are too warm and acidic to absorb it, and the dead forests are no longer breathing it in. The concentration of CO2 in the atmosphere climbs to terrifying levels, perhaps 10 times higher than our own. The world is now a silent, shimmering superheated greenhouse. The air is a toxic stagnant soup. The oceans are a warm, breathless, poisonous broth. The land is a sterile, baked desert. It seems the catastrophe has reached its absolute peak. The planet has thrown its worst at its inhabitants. But deep on the floor of the warming ocean, in the dark pressurized mud, the planet's fever is about to awaken one last monster. A monster made of ice and fire. Section 6. The monster from the seafloor. Just when it seemed the world could not possibly become more hostile, a new sound begins to be heard. It is not a sound that travels through the air, but through the water and the rock. It is a deep planetary rumbling. A vast fizzing hiss that emanates from the continental shelves and the deep ocean floor. The planet has begun to belch. The monster, hidden for millions of years in the cold, pressurized darkness, is waking up. To understand this monster, we must travel back in time, long before the extinction began. For eons in the cold mud of the seafloor, a strange substance had been forming. As tiny organisms died and sank, their organic matter was consumed by microbes in the oxygen-poor sediment. Under the immense pressure of the deep sea and at the frigid temperatures near freezing, these microbes produced methane gas. Normally, this methane would bubble up and escape. But under these specific conditions of high pressure and low temperature, a strange kind of alchemy occurs. The methane gas is trapped within a crystalline cage of frozen water molecules. The result is a substance that looks like white, waxy ice, but it is not ice. It is methane hydrate or fire ice. It is a solid, stable form of frozen methane, locked away in colossal quantities within the sediments of the seafloor. A vast sleeping reservoir of a greenhouse gas far more potent, molecule for molecule, than carbon dioxide. For millions of years, this fire ice has been held in a delicate balance, kept stable by the cold and the crushing pressure of the ocean above. It is a sleeping dragon, its hoard of carbon locked away in a frozen prison. But now the planet's fever, driven by the Siberian trap CO2, has reached the dragon's lair. The oceans have warmed, not just at the surface but slowly, relentlessly. The heat has penetrated down into the deeps. The temperature of the bottom water begins to rise, degree by agonizing degree. It creeps past the critical threshold at which the methane hydrates can remain stable. And the fire ice begins to melt. Imagine a vast submerged field of this white, waxy substance. As the water warms, the crystalline cages of water molecules lose their integrity. They fall apart, and the methane gas trapped inside is suddenly liberated. It is a phase change of terrifying power. A solid turning directly into a massive volume of gas. The seafloor begins to erupt, not with lava but with bubbles. Colossal plumes of methane gas, released from their frozen slumber, burst from the sediment and begin their journey to the surface. The ocean, which had been so stagnant and still, is now churning with these rising columns of gas. It is as if the sea itself is boiling, not from heat, but from the release of this ancient, trapped breath. The sound is a deafening, effervescent roar. The sheer force of this gas release can trigger massive submarine landslides, sending entire continental shelves slumping into the abyss, which in turn releases even more methane. It is a feedback loop from hell. Warming oceans melt the hydrates, which release methane. Methane is a powerful greenhouse gas, which traps more heat in the atmosphere, which further warms the oceans, which melts more hydrates. The dragon is not just awake. It is feeding itself, growing stronger with every passing moment. As these immense bubbles of methane reach the surface of the ocean, they burst into the already choked atmosphere. The effect on the global climate is almost instantaneous. If the CO2 from the volcanoes was a blanket, the methane is a thick, suffocating feather duvet thrown on top. Global temperatures, already at a scorching high, take another terrifying leap upwards. The fever intensifies. The dead zones at the equator expand. The last, most resilient ecosystems on Earth are pushed beyond their breaking point. This massive injection of methane has another insidious effect. As it rises through the water column, it is consumed by bacteria, which use up even the last vestiges of oxygen in the already anoxic waters. And in the atmosphere, the methane oxidizes into, you guessed it, more carbon dioxide and water vapor, adding to the long-term greenhouse problem even after its own short-term superheating effect has passed. It is a multi-pronged assault that poisons the oceans and cooks the atmosphere. For any life still clinging to existence, this is the final incomprehensible blow. The Lystrosaurus, hiding in its burrow, would feel the ground shake with the submarine convulsions. It would emerge into an atmosphere that has become even hotter, even more suffocating. The very air is shimmering not just with heat, but perhaps with the strange hazy hydrocarbons being released. And what of the hydrogen sulfide, the poison gas being produced in the anoxic oceans? Some scientists hypothesize a truly apocalyptic scenario, the Vernian event, named after Jules Verne. They imagine a world where the ocean stratification eventually breaks down catastrophically. The deep, poisonous, sulfitic water, now supercharged by the methane release, erupts to the surface in a massive ocean burp. Imagine a vast plume of this toxic water upwelling, releasing a cloud of hydrogen sulfide gas into the atmosphere. This gas would not only be a deadly poison to any air-breathing life it encountered, but it would also viciously attack the already shredded ozone layer, completing its destruction. The world would be a hot, stinking, irradiated wasteland. The sky might even take on a sickly greenish-yellow hue. This is the most extreme and still debated vision of the Permian apocalypse, but it illustrates the sheer number of interlocking, self-reinforcing catastrophes that were at play. The monster from the seafloor, the methane hydrate feedback loop, represents the point of no return. It shows how a planet's climate system, once pushed past a certain tipping point, can enter a runaway state, with internal processes taking over and amplifying the initial catastrophe far beyond its original scale. The initial trigger was the volcanoes, but the planet itself, through its own complex chemistry and geology, became its own worst enemy. The Earth is now unrecognizable. It is a truly alien planet, a hellscape forged by fire, acid, heat, and poison. The symphony of life has been silenced. The forests are gone. The reefs are rubble. The giants are bones. The sky is a venomous veil, and the ocean is a stagnant tomb. The question is no longer what will die. The question now is, how could anything anywhere possibly survive? Section 7, The Great Silence. Let us now pull our consciousness back from the chaos of the erupting seafloor and the scorching sky. Let us simply hover, like a weightless observer, and witness the world that these compounding catastrophes have created. The roaring of the volcanoes has quieted. The fizzing of the methane has subsided. The violent, feverish phase of the extinction has passed. And what is left behind is a profound and unnerving stillness. A great silence has fallen over the earth. Survey the land. The single vast continent of Pangaea lies prostrate under a heavy, hazy sky. The sun is a pale, bloated disk, its light diffuse and sickly. The once great Glossopteris forests are gone. In their place stand skeletal groves of dead, blackened trunks, silent and unmoving. There is no rustle of leaves, for there are no leaves. There is no birdsong, for birds have not yet evolved, and their reptilian analogues have long since vanished. The only sound is the whisper of a hot, dry wind blowing dust through these ghost forests. The ground is bare. The rich soils that took millions of years to form have been stripped away by acid rain and flash floods, leaving behind sterile, cracked dirt and exposed rock. The vast fern prairies are now plains of gray dust. There are no insects buzzing in the thick air. The intricate world of the Permian invertebrates, the foundation of so many food webs, has collapsed. The giant hawk-sized dragonflies are gone. The world is eerily clean of the small, skittering things that once filled every niche. Look for the great beasts. The mighty gorgonopsians are nowhere to be seen. Their bones lie scattered and bleached in the dry riverbeds, their terrifying saber teeth grinning at a sky that offered no mercy. The armored Scutosaurus are gone, their bony plates half buried in the dust, the last remnants of a failed dynasty of terrestrial titans. All the large herbivores and carnivores, the products of a long and stable evolutionary arms race, have been comprehensively wiped out. Their size, their specialization, their power, all the things that made them successful in the old world became fatal liabilities in the new. The planet has been swept clean of its kings. The rivers themselves are ghosts. They are no longer the vibrant, life-filled arteries of the continent. They are sluggish, shallow trickles of alkaline, soupy water, choked with white microbial mats, the only organisms that can tolerate such toxic conditions. They flow through banks of dead vegetation, carrying no fish, no amphibians, only the silence of a chemically defeated ecosystem. Let your senses drift out over the great ocean Panthalassa. It stretches to the horizon, a placid, glassy surface under the hazy sun. But its calmness is the stillness of a tomb, not of peace. There are no splashes from leaping fish, no whales breaching, they are still far in the future. No seabirds crying. The surface is unnervingly flat. Beneath that surface lies the stratified horror we have already witnessed. The thin, warm, oxygen-poor upper layer is a microbial soup. The deeps are a black, sulfitic, poisonous void. The great reefs, once the vibrant cities of the sea, are now crumbling necropolises, their calcium carbonate skeletons slowly dissolving back into the acidic water. The trilobites are gone. After a reign of more than 250 million years, a span of time almost unimaginable to us, the last one has perished, its lineage extinguished forever. The ammonites, the brachiopods, the ancient corals, countless dynasties of the sea have been brought to a sudden, brutal end. An estimated 95% of all marine species have vanished. The ocean's biodiversity has been reset to almost zero. This is a world of ghosts. The biomass of the planet has been so catastrophically reduced that the very carbon cycle has been altered. For a time, the planet is dominated not by animals or plants, but by fungi. Imagine the landscape covered in a strange, pale fuzz. Fungal spikes, as they are known from the fossil record, show a world where the primary ecological role is decomposition. The world is rotting. Vast ecosystems of fungi and microbes feast on the endless dead organic matter left behind by the extinction, a last ghoulish supper on a planetary scale. This is the great simplification. The intricate, complex web of life, woven over countless millennia, has been shredded. What is left are the generalists, the opportunists, the specialists in survival itself. The world has been returned to a primal state, a blank slate of rock and dust and poisoned water. The silence is the sound of a billion empty niches. It is the sound of evolutionary pathways cut short, of futures that will never happen. The potential for countless forms, beautiful and strange, has been erased. It is difficult for us, living in a world so rich with complex life, to truly imagine such emptiness. To stand on a continent and know that for 1,000 miles in any direction, there is nothing larger than a small lizard. To look at an ocean and know that it is almost entirely sterile. The sheer, overwhelming loneliness of it. And yet life is not entirely gone. It has been pushed to the very brink of annihilation, but it has not been extinguished. In the most marginal of habitats, in the deepest burrows, in the most resilient of forms, a few sparks still flicker in the overwhelming dark. Life has been cut down to the root, but the root in some places still holds. The survivors are not the strong, not the large, not the specialized kings of the old world. They are the humble, the hardy, the overlooked. They are the creatures who were, by some fluke of biology or behavior, pre-adapted to survive hell. And from these few traumatized survivors, the Earth will have to rebuild its entire biosphere. The great silence is the pause, the deep, shuddering breath the planet takes after the fever breaks. It is the prelude to the slowest, most arduous dawn the world has ever known. Section 8. the unlikely heirs. In the deafening silence of the post-extinction world, on the desolate, sun-scorched plains of Pangaea, something begins to stir. It is not the return of the giants, nor the ghost of a predator. It is something small, persistent, and almost comically out of place in the vast emptiness. A blunt-nosed head with two sturdy tusks emerges from a hole in the baked earth. It blinks in the harsh, hazy sunlight. It senses sampling a world scrubbed clean of its former terrors and its former abundance. This is Lystrosaurus. This is the face of a survivor. Before the cataclysm, Lystrosaurus was just one creature among many. A common, unremarkable, pig-sized herbivore, part of the background noise of the Permian. It was prey for the great Gorgonopsians and a competitor to other plant eaters. But now, in the aftermath, it is virtually the only thing left. In some fossil beds from the early Triassic period, immediately following the extinction, Lystrosaurus fossils make up 95% of all terrestrial vertebrate remains. This is not just survival, this is domination by default. The meek have quite literally inherited the earth. So what was their secret? What allowed this humble dicynodont to walk through the fire that consumed titans? It wasn't one single trait, but a suite of lucky adaptations, a survival toolkit that it never knew it would need. Let's start with its most obvious habit. It was a burrower. While the planet's surface was swinging between the extremes of volcanic winter and scorching greenhouse heat, and being bombarded with acid rain and UV radiation, Lystrosaurus could retreat into the shelter of the earth. Its burrow was a buffer, a microenvironment that protected it from the worst of the apocalypse raging above. The soil insulated it from the temperature swings and shielded it from the poisonous light. While other animals were exposed and cooked, Lystrosaurus simply waited it out underground. Then there was its diet. It was not a fussy eater. It didn't rely on the delicate leaves of the Glossopteris trees. Its powerful beak and tusks were perfectly adapted for digging up the tough, starchy roots and tubers that grew underground. These plant storage organs were like disaster bunkers for the plant kingdomable to lie dormant and survive the surface chaos, ready to sprout again when conditions improved. While the herbivores that fed on leaves and shoots starved, Lystrosaurus could always find something to eat by digging in the dirt. It was a pre-built advantage for a world whose salad bar had been permanently closed. Its physiology also seems to have been uniquely suited for the hostile new atmosphere. Studies of its bone structure and nasal passages suggest it may have had a highly efficient respiratory system. In a world with lower oxygen levels and higher carbon dioxide, this would have been a crucial advantage. Perhaps it could tolerate the toxic air better than its contemporaries. Some scientists even speculate that its barrel-chested build housed large, powerful lungs, allowing it to thrive in the thin, stagnant air of the early Triassic. It was, in essence, the high-altitude mountaineer of its time, able to breathe where others suffocated. Furthermore, its generalist, weed-like lifestyle was a key to its success. It was not tied to a specific habitat, could live almost anywhere. As the world emptied out, Lystrosaurus spread. It became a walking, digging, eating monoculture across the entire supercontinent of Pangaea. Its fossils are found from what is now South Africa to Russia to Antarctica, demonstrating its incredible ability to colonize and dominate the desolate landscapes. It was a pioneer species on a planetary scale. It grew fast, reproduced quickly, and died a life strategy perfect for refilling a world full of empty niches. Imagine the world from the perspective of one of these creatures. You emerge from your burrow. The world is quiet. The shadows of the great predators no longer haunt the edges of the ghost forests. The rumbling footsteps of the giant herbivores no longer shake the ground. The world is empty and it is yours. There is no competition. There are no threats. There is only the endless, silent expanse of a traumatized planet, and the tough, buried roots that promise another day of life. But Lystrosaurus was not the only heir. It was simply the most prominent. In the shadows, other, Even smaller stories of survival were unfolding. Hiding in the leaf litter, in tiny burrows, and among the rotting logs, were other synapsids or own distant relatives. Creatures like Thrinaxodon, a small shrew-like animal, perhaps warm-blooded, perhaps covered in a downy fur. It survived by being small, fast, and inconspicuous. It hunted the few remaining insects and grubs, living in the margins, a tiny furtive creature in a world of giants that had now fallen. From creatures like this, the first true mammals would eventually arise. They were the understudies, waiting in the wings while the Lystrosaurus dynasty had its brief, strange moment on center stage. And there was another group too. The archosaurs, the ruling reptiles. Before the extinction, they were a minor group, overshadowed by the dominant synapsids like the Gorgonopsians. But some of them survived. Small, lizard-like creatures, perhaps better able to cope with the heat and aridity. They were biding their time. In the vacuum left by the fallen synapsid kings, these archosaur survivors would eventually give rise to a new dynasty of terrestrial rulers. They would evolve into the crocodiles, the pterosaurs, and, most famously, the dinosaurs. The Great Dying, by wiping the slate clean, inadvertently cleared the way for the 150-million-year reign of the dinosaurs. The story of the heirs is a story of profound irony. The apocalypse was not a test of strength, but of resilience. It did not reward the powerful, but the adaptable. It didn't favor the specialized, but the generalist. Lystrosaurus was the ultimate disaster taxon, a creature perfectly, accidentally suited to an imperfect world. Its dominance was a sign not of a healthy ecosystem, but of a profoundly broken one. It was the lonely king of a ruined kingdom, a placeholder until the slow, painstaking process of rebuilding could begin, and new, more complex forms of life could once again inherit the earth. Section 9: The Slow Dawn. The reign of Lystrosaurus, the lonely king, could not last forever. Its dominance was a symptom of a sick planet, and as the earth slowly began to heal, the conditions that allowed for its near monoculture started to change. The age of the disaster opportunist gave way to the age of the specialist. The slow dawn of a new world, the Triassic period, had begun, but it was a dawn that would take millions of years to fully break. The planet itself had to recover first. The Siberian traps eventually fell silent. The immense volcanic province cooled and settled, no longer pumping poison into the atmosphere. With this primary source of carbon dioxide shut off, the planet's natural carbon sinks could slowly, painstakingly begin their work. The ocean, though devastated, was key to this recovery. Over thousands and thousands of years, the shells of dead plankton and other tiny organisms rained down into the deep, locking away carbon in new layers of sediment. On land, the first hardy, disaster-ready plants began to reclaim the sterile ground. Not the majestic Glossopteris of the Old World, but tough, scraggly, opportunistic species like the conifer Voltsia and the horsetail-like Pluramia. They were the botanical equivalent of Lystrosaurus, resilient, and able to grow in the impoverished, contaminated soils. As these new sparse forests began to spread, they started to breathe again. Photosynthesis, the engine of life, slowly drew down the atmospheric CO2, molecule by painful molecule. This had a dual effect. It reduced the greenhouse effect, allowing the planet's fever to finally break and the global climate to stabilize. And it began to pump precious oxygen back into the atmosphere. The world was slowly becoming more breathable, more temperate, more hospitable. This process was agonizingly slow. The fossil record shows that for the first 5 to 10 million years of the Triassic, ecosystems remained profoundly impoverished. It was a coal gap, a period where so little biomass was being produced and buried that no new coal seams were formed. The planet was a shadow of its former green self. The ghost of the Great Dying lingered for a geological age. But life, given even the slightest opportunity, is relentless. The initial simplicity of the post-extinction world began to give way to new complexity. The world of the lone Lystrosaurus started to get more crowded. The other survivors, the ones who had been hiding in the margins, began to emerge and diversify, stepping into the countless empty roles left behind. Remember the archosaurs, the ruling reptiles, that were a minor group before the extinction? This was their moment. In the hot, arid landscapes of Triassic Pangaea, their reptilian physiology gave them an edge. They diversified with explosive speed. A classic example of an adaptive radiation. One branch gave rise to the crocodilian line, ambush predators that reclaimed the slowly recovering rivers. Another branch evolved into the pterosaurs, the first vertebrates to conquer the air, their leathery wings casting new and unfamiliar shadows on the ground below. And then there was the third, most famous branch, the dinosaurs. They started small. Creatures like Eoraptor, a nimble two-legged carnivore no bigger than a fox. They were fast, agile, and efficient. They were not yet the titans of the Jurassic, but they were a new and highly successful evolutionary experiment. They began to outcompete the last of the Lystrosaurus dynasty and the other surviving synapsids. The world was witnessing a changing of the guard. The age of mammal-like reptiles was truly over, and the age of dinosaurs was dawning. Our own distant ancestors, the surviving synapsids, did not go extinct, but they were pushed into the shadows. Creatures like Thrinaxodon and its descendants became small, nocturnal insect eaters. They survived by staying out of the way of the new ruling class. For the next 150 million years, our lineage would live a furtive life at the feet of the dinosaurs, a long, patient waiting game in the twilight, developing key mammalian traits: warm-bloodedness, fur, complex teeth, larger brains that would one day serve them well when another later mass extinction would again reset the board. In the oceans, the recovery was just as slow but equally profound. The anoxic, sulfitic waters eventually reoxygenated as global circulation patterns restarted. The acidic conditions abated, and into this empty aquatic world, new life forms radiated. The few species of ammonites that survived the bottleneck diversified into a dizzying array of new shapes and sizes. New types of corals appeared, the scleractinian corals that build the reefs we know today, and began the slow work of constructing new cities beneath the waves. And new predators emerged in the sea. From the land, a group of reptiles returned to the water, evolving into the sleek, dolphin-like ichthyosaurs and the long-necked plesiosaurs. They became the new apex predators of the marine realm, replacing the strange sharks and giant sea scorpions of the Permian. The ocean was being repopulated with a completely new cast of characters. This slow dawn was a process of rebuilding the entire biosphere, brick by brick, from the handful of survivors that made it through the fire. Every ecosystem, from the soil microbes to the apex predators, had to be reconstructed. It demonstrates one of the most profound truths of our planet's history. Life is incredibly resilient, but complexity is fragile. Biodiversity, once lost, takes millions of years to recover. The world that emerged from the ashes of the Great Dying was a completely different planet from the one that had entered it. The Permian world was gone forever, an alien landscape populated by ghosts. The Triassic world, born from its trauma, set the stage for the world we know, the world of dinosaurs, mammals, and eventually us. The Great Dying was the most profound rupture in the history of life, a planetary near-death experience. But in its destructive wake, it created a new kind of creative potential. By wiping the slate clean, it allowed for evolutionary experiments that would have been impossible in the crowded, stable world of the Permian. It was a terrible, brutal, but ultimately creative force, a crucible that burned away the old world to make way for the new. Section 10. Lessons from a Ghost World. And so our long journey through deep time is nearing its end. We have walked the vibrant forests of a world before our own, felt the ground tremble with the planet's fever, and listened to the profound silence that followed. We have watched the lonely reign of the survivor, Lystrosaurus, and witnessed the slow, patient dawn of a new era. Now, as your breath deepens and sleep draws near, Let us gently pull our consciousness back from that ghost world, across the immense chasm of 252 million years, and let it settle here in the quiet of this present moment. For the story of the Great Dying is not just a fossilized memory locked in ancient stone. It is a living echo. It is a cautionary whisper carried on the winds of deep time, and if we listen closely in the stillness of the night, we can hear it resonate in our world today. The Earth has a long memory, and it tells its stories in patterns. The prime mover of that ancient apocalypse, the colossal outpouring of carbon dioxide from the Siberian traps, has a familiar ring. The planet showed us then what happens when its atmosphere is thickened, when its ability to radiate heat into space is compromised. Today we see the echo of that process not in a single vast volcanic province, but in the millions of tiny smokestack volcanoes, our cars, our power plants, our industries that are steadily releasing that same ancient buried carbon back into the sky. The Earth's slow-motion fever, the one that baked Pangea, is a story the planet has told before. We are, in our own way, writing a new chapter. The silent, chemical whisper of the acid rain that dissolved the skin of the Permian world can be heard today in the plight of our own oceans. As they absorb the excess carbon from our atmosphere, they too are becoming more acidic. The very same chemical laws that made it impossible for Permian corals and ammonites to build their shells are now a threat to our own vibrant reefs, and the countless tiny shelled creatures that form the foundation of our marine food webs. The breathless sea of Panthalassa is a stark reminder of what happens when the ocean's chemistry is pushed too far, too fast. The monster from the seafloor, the runaway release of methane hydrates, serves as the most profound lesson on the planet's hidden tripwires. It teaches us that a planetary system is not always linear or predictable. It contains tipping points, thresholds beyond which the system begins to drive itself, amplifying the initial problem in a terrifying feedback loop. It reminds us that there are forces locked within the ear-thin the permafrost, in the deep sea that are stable now, but may not remain so in a rapidly warming world. But the story of the Great Dying is not just a litany of warnings. It is also a profound lesson in fragility and resilience. It teaches us that complexity is a precious and delicate gift. The Permian world was the product of hundreds of millions of years of stable evolution, a rich and intricate tapestry of life. The extinction showed how quickly that tapestry can be unraveled, how the strong and the specialized are often the most vulnerable when the fundamental rules of the world are rewritten. It instills in us a deep and humbling respect for the intricate biodiversity of our own time, a web of life that once broken would take millions of years to weave anew. And yet, it is also a story of incredible resilience. Life was pushed to the very razor's edge of existence, but it did not let go. In the survival of the humble Lystrosaurus, the furtive Thrinaxodon, and the other overlooked heirs, we see life's tenacious, indomitable spirit. Life finds a way, not always in the forms we expect, but in the forms that endure. The extinction was a bottleneck, a crucible that burned away an old world but, in doing so, forged the raw material for the new. Without the Great Dying, there would have been no age of dinosaurs. Without the fall of the dinosaurs, there would have been no age of mammals. And without the age of mammals, there would be no us, here now, contemplating it all. The greatest lesson from this ghost world may be one of perspective. To look back on such a vast and ancient catastrophe is to understand our own moment in a new light. It connects us to the deep, slow rhythms of the planet, to the immense cycles of creation and destruction that have shaped all that we know. It reminds us that we are not separate from this planet. We are a part of its unfolding story, a fleeting but potent force within its ancient and complex systems. The Earth has survived catastrophes far greater than any we could imagine. The question is not whether the planet will survive us, but in what state we will leave it for the next unlikely heirs to inherit the slow dawn that follows. Our journey through deep time comes to a close. We leave the ghost forests and the breathless seas of the Permian behind, letting them settle back into the quiet stone of the planet's memory. Feel the immense weight of those millions of years, not as a burden, but as a deep and grounding peace. All that drama, all that upheaval, all that loss, and all that slow, patient recovery have led to this moment, to you resting here now. Your own life is a tiny, brilliant flicker in that vast expanse of time, a precious and improbable miracle. Let the scale of this ancient story quiet your mind, putting all the small worries of the day into their proper perspective. They are like grains of sand on the shore of the great Panthalasan Ocean. Let them be washed away by the gentle tide of sleep. The world will continue its slow, silent turning, as it has for ages. And now it is time for you to rest. Sleep well and may your dreams be peaceful.